Gotthard Base Tunnel, Switzerland, the world's longest railway tunnel, opened in 2016, running 57.1 kilometers under the Swiss Alps. It's the centerpiece of the new railway link through the Alps, NRLA, designed to move freight and passengers efficiently across Europe's north-south axis. Two parallel single-track tubes, connected by cross passages every 325 meters. Excavation used both tunnel boring machines and drill and blast. Spoil was recycled into concrete aggregates and used to build artificial islands. Ventilation caverns and emergency stations were installed at Sedrun and Fado. It's designed for trains up to 250 kilometers an hour, equipped with overhead electrification at 15 kilovolts and ETCS Level 2 signaling. Flat gradient of just 0.8% allows freight trains up to 3,600 tons to pass without extra locomotives. Zurich to Milan travel time was cut by about 45 minutes. Around 260 freight trains and 65 passenger trains use the tunnel daily, shifting millions of tons of cargo from trucks to rail and easing Alpine road congestion. It cost about 12 billion Swiss francs, roughly 11 billion euros, funded mainly by Swiss federal funds through dedicated transport taxes and EU contributions. Grand Paris Express, France, a 200-kilometer expansion of the Paris Metro, adding 68 new stations to link the suburbs together without passing through the city center, targeting about 2 million passenger trips per day. The four entirely new, fully automated orbital and radial lines, 15, 16, 17, 18, plus extensions of lines 11 and 14, reconfigure commuting flows, shorten cross-suburb trips, and increase capacity across the region. About 90% of the new network is underground, driven mainly by tunnel boring machines installing precast concrete segments to form twin running tunnels. Station boxes are excavated from the surface with diaphragm walls and struts before being fitted out. The program bundles hundreds of contracts for civil works, systems, and stations to run in parallel across the region. The French multinational rail transport systems manufacturer, Alstom, is supplying 183 driverless Metropolis train sets, MR6V6 car sets, roughly 108 meters, up to roughly 960 passengers, for lines 15, 16, 17, and shorter 3-car MR3V sets, roughly 47 meters, up to roughly 350 passengers, for line 18. Trains run under automated control with platform screen doors, high peak throughput, and short headways to match demand. Line 14's north-south extension opened on the 24th of June 2024 ahead of the Olympics. Testing and first trains for Line 18 began in 2025. Other sections of Lines 15, 16, 17 open in stages from the late 2020s. The network provides direct links between major suburban hubs and new interchanges, for example, Saint-Denis-Pleyel, and connects to airports and high-speed rail, removing transfer pressure from central Paris corridors and cutting door-to-door times for orbital trips. The official objective cost is 36.1 billion euros in 2012 euros. Société de Grands Projets. Later updates put the program around 42 billion euros in 2020 euros. While France's Cour des Comptes has warned broader total expenditures linked to the program could reach higher when ancillary items are included. Funding combines dedicated Île-de-France taxes, large green bond issuances, over 26 billion euros placed since 2018, and EIB loans. Fehmarnbelt Fixed Link, Denmark, Germany. A planned 18-kilometer immersed tube tunnel under the Baltic Sea linking Rodbyhaven in Denmark with Puttgarden in Germany. It will carry a 4-lane motorway and a double-track electrified railway, cutting the Copenhagen-Hamburg rail trip from nearly 5 hours to about 2.5. The project replaces a slow ferry crossing, creating a high-capacity, all-weather corridor between Scandinavia and continental Europe. The design is an immersed tube tunnel, not bored. About 89 standard concrete elements, 217 meters long each, weighing around 73,000 tons, plus 10 shorter service elements are cast in a vast purpose-built factory at Rodbyhaven. These elements are flooded out, immersed in a dredged trench, and covered with gravel and stone. This method is chosen over a cable-stayed bridge to limit wind exposure, reduce maintenance, and minimize impact on aircraft flight paths and shipping. There are 2 separate road tubes with 2 lanes each, and 2 rail tubes with a central service gallery. The railway tubes are dimensioned for 200-kilometer-an-hour electrified passenger trains and heavy freight. The tunnel's fitted with cross passages every 50 meters for emergency access, automatic ventilation, and advanced fire safety systems modeled on the Øresund and Channel tunnels. Car and truck travel times are cut by about an hour compared to the ferry. Freight trains gain a direct, faster corridor between Scandinavia and Central Europe, reinforcing the 10T core network. The link also integrates with Denmark's upgraded Ringsted-Fehmarn Railway, which is being double-tracked, electrified, and fitted with ETCS signaling to handle the expected traffic. Construction cost is estimated at 7.4 billion euros in 2016 prices, of which Denmark covers the majority through state-guaranteed loans to be repaid from future user tolls. Germany finances on-land connecting works. The projects received EU Connecting Europe facility grants. Construction began officially in 2021 with factory, dredging, and work harbor setup. Production of the concrete elements is underway, with the first immersion scheduled for 2026. The target opening date is 2029. HS2 High Speed 2, United Kingdom. A new high-speed railway designed to link London with Birmingham, Manchester, and beyond at speeds of up to 360 kilometers an hour. Phase 1, from London Euston to Birmingham Curzon Street, forms the core now under construction. The aim is to increase rail capacity, reduce travel times, and relieve congested Victorian main lines, particularly the West Coast Main Line. The project combines long tunnels, massive viaducts, and entirely new alignments. 2 parallel 10-mile-long tunnels are being bored under northwest London. The Chiltern tunnels, excavated with tunnel boring machines nearly 170 meters long. Viaducts like Colne Valley, 3.4 kilometers, are built with precast concrete segments lifted into place, spanning reservoirs and wetlands. Stations such as Old Oak Common are designed with 14 platforms and space for seamless transfers to Crossrail, Heathrow Express, and Great Western lines. HS2 is being equipped with ETCS, European Train Control System, Level 2 signaling for continuous automatic control, overhead catenary electrification at 25 kilovolts, and specially designed trains that can operate on both high-speed tracks and conventional rail for through services. The design speed of 360 kilometers an hour will make it the fastest railway in Europe once operational. It's expected to carry up to 300,000 passengers per day. London-Birmingham travel times will fall from about 1 hour 20 minutes to 45 minutes. The freed-up capacity on existing tracks allows for more commuter and freight trains, redistributing demand across the network. Phase 1's cost is estimated at 45 to 55 billion pounds. The entire program has faced revisions, with Phase 2 to Manchester currently deferred or curtailed. Financing is through direct government capital investment from the UK Treasury. Main works for Phase 1 started in 2020. Major tunnels, viaduct piers, and stations are under construction. The target opening is in the early 2030s, subject to progress and political review. Brenner Base Tunnel, Austria, Italy. A 55-kilometer twin-tube railway tunnel under the Eastern Alps between Innsbruck, Austria, and Fortezza, Italy. Once finished, it'll be the longest underground rail connection in the world. The tunnel bypasses the steep, winding Brenner Pass route, enabling flat-grade, high-capacity rail for both freight and passengers. It's a central piece of 10T Scandinavian Mediterranean corridor, shifting long-haul traffic from road to rail across the Alps. 2 single-track tubes, each 8.1 meters in diameter, run parallel and are linked every 333 meters by cross passages. A separate 5-meter diameter exploratory tunnel is being driven in advance along the full alignment to study geology and groundwater behavior. Excavation combines tunnel boring machines with drill and blast and more complex geology. Spoils reused to make concrete or deposited in engineered sites. Ventilation shafts at intermediate access points such as Arental, Fons, and Mules provide logistics access during construction. The design allows for trains up to 250 kilometers an hour for passengers and 160 kilometers an hour for freight. Overhead 25 kilovolt electrification and ETCS Level 2 signaling will be installed. Gradient is held at only 0.4%, allowing heavy freight trains to cross without additional locomotives, unlike the existing Brenner line. By removing the bottleneck of the Alpine climb, the tunnel will cut Munich-Verona travel to about 3 hours and sharply reduce truck congestion on the Brenner motorway. Annual capacity is projected at 400 trains per day, equivalent to shifting tens of millions of tons of freight from road to rail and reducing CO2 emissions in the Alpine corridor. Current estimates place the cost at around 10 billion euros. Funding is shared by Austria, Italy, and the European Union. which has designated it a priority project and provides up to 40% co-financing for cross-border sections. Exploratory work started in 2006. Main excavation has been underway since the 2010s. About 80% of the total tunnel length has been excavated as of the mid-2020s. The scheduled completion and opening is around 2032. ITER, International Thermonuclear Experimental Reactor, France, the world's largest experimental nuclear fusion facility, under construction at Saint-Paul-de-Durance in southern France. The goal is to prove that fusion power can produce more energy than it consumes, paving the way for commercial reactors. ITER is designed to generate 500 megawatts of thermal power from 50 megawatts of input for pulses lasting 400 to 500 seconds, achieving a 10-fold energy gain factor, Q equals 10. At the heart of ITER is a tokamak, a donut-shaped vacuum vessel surrounded by superconducting magnets that confine plasma at temperatures of over 150 million degrees Celsius. The site includes one of the largest cryogenic plants in the world to cool the magnets to 4 Kelvin, assembly halls for reactor components delivered from 35 partner countries, and specialized cranes capable of lifting over 1,500 tons. The vacuum vessel consists of 9 massive stainless steel sectors, each weighing over 400 tons, assembled like slices of an orange. The plasma is heated by multiple methods: neutral beam injection, radio frequency waves, and ohmic heating. A tritium breeding system is tested in blanket modules around the vacuum vessel to explore self-sufficient fuel cycles. Remote handling robots are installed for maintenance inside the highly radioactive environment. The superconducting magnets, including the 24 poloidal field coils, are among the largest ever built. ITER is a collaboration among the European Union, China, India, Japan, Russia, South Korea, and the United States. Europe provides about 45% of the construction costs, with other partners sharing the rest mainly through in-kind contributions of components. Thousands of scientists and engineers worldwide contribute to design, fabrication, and assembly. The total lifetime cost is estimated at around 20 billion euros, making ITER one of the most expensive science projects ever. Europe bears nearly half of this, with the remainder divided among the other partners. Site works began in 2010. Major component installations been ongoing through the 2020s. First plasma was originally targeted for 2025 but has been delayed. Current planning points toward the early 2030s for full power operation. Øresund Bridge Tunnel, Denmark, Sweden. A combined road and rail fixed link between Copenhagen, Denmark, and Malmö, Sweden, opened in 2000. It consists of an 8-kilometer cable-stayed bridge, a 4-kilometer artificial island, Pebberholm, and a 4-kilometer immersed tube tunnel leading into Copenhagen. It's a critical transnational artery for both commuters and freight, integrating the economies of southern Sweden and eastern Denmark. The bridge carries 2 levels, an upper deck with 4 motorway lanes and a lower deck with 2 railway tracks. The bridge pylons rise 204 meters above sea level, supporting a 490-meter main span. The immersed tunnel section was chosen on the Danish side to avoid interference with flight paths from Copenhagen Airport and shipping lanes. Precast tunnel elements, each about 176 meters long, were immersed in a dredged trench. More than 20,000 vehicles and around 40,000 rail passengers cross daily. The link has transformed commuting patterns, enabling daily cross-border travel for work and study. Freight trains use the rail section to move goods across Scandinavia and Europe. The construction cost was around 4 billion euros. Financing was arranged through state-guaranteed loans, to be repaid entirely from user tolls over decades. Crossrail, Elizabeth Line, United Kingdom. A 118-kilometer rail project across London, officially opened in 2022 under the name Elizabeth Line. It integrates new tunnels under central London with upgraded existing surface lines. The goal is to add about 10% more rail capacity to the capital, relieving congestion on the underground and connecting Heathrow Airport, Canary Wharf, and central London directly. 42 kilometers of twin-bore tunnels were excavated under the city using 8 tunnel boring machines. New cavernous underground stations were built at Tottenham Court Road, Bond Street, and Canary Wharf, with lengths exceeding 200 meters to fit full 9-car trains. Advanced fire safety, platform screen doors, and heavy-duty ventilation systems were installed. The Elizabeth Line carries over 200 million passengers annually. Travel times across London have been cut significantly. For example, Heathrow to Canary Wharf dropped from nearly 1 hour to just over 30 minutes. The line integrates with National Rail, London Underground, and Thameslink, The final cost reached about £18.9 billion, funded through a combination of UK government grants, local business levies, and transport for London borrowing. Lyon-Turin rail link, France, Italy. A new high-speed rail connection through the Alps, anchored by a 57.5-kilometer base tunnel under Mont-Cenis, between Saint-Jean-de-Maurienne, France, and Susa, Italy. The project's designed to shift freight and passengers from congested Alpine motorways onto rail, forming part of the 10T Mediterranean corridor. The Mont-Cenis base tunnel consists of two parallel single-track tubes connected by cross passages. Multiple access adits and shafts provide simultaneous excavation fronts. Tunnel boring machines and drill and blast are both employed depending on geology. Above-ground works include upgraded approach lines in both France and Italy. It's designed for passenger trains at up to 220 kilometers an hour and freight trains at up to 120 kilometers an hour. Electrified at 25 kilovolts with ETCS signaling, the tunnel gradient is kept below 0.85% to allow heavy freight loads. It'll cut Lyon-Turin travel times from over 4 hours to around 2. The link will remove up to 1 million trucks annually from Alpine roads, reducing pollution and noise in sensitive valleys. The overall program's estimated at 25 to 30 billion euros. The EU covers up to 40% of cross-border costs, with the remainder shared between France and Italy. Preliminary works began in the 2010s. As of the mid-2020s, over 30 kilometers of the base tunnel had been excavated. Completions aim for the early 2030s. Sagrada Família completion. Spain. Antoni Gauda's Basilica in Barcelona, begun in 1882, is one of Europe's longest-running megaprojects. It is simultaneously a monumental work of art and an active place of worship. The current phase focuses on completing the main towers, including the 172.5-meter-high Tower of Jesus Christ, which will make it the tallest church building in the world. Modern digital modeling and CNC stone cutting machines now accelerate work that once depended solely on hand carving. Prefabricated stone and reinforced concrete elements are lifted into place by cranes and fitted with precision. The design combines traditional Gothic load-bearing with hyperbolic and catenary geometries that distribute forces efficiently. It is one of the most visited monuments in Spain, attracting over 4.5 million tourists annually. When complete, it'll contain 18 towers symbolizing biblical figures, vast interior vaults, and acoustics designed for large-scale liturgical music. The project is entirely funded by private donations and ticket sales. The overall cost is difficult to estimate precisely, but runs into hundreds of millions of euros. Current completion target is around 2033, aligning with the 150th anniversary of Gauda's death. Hinkley Point C Nuclear Power Station, United Kingdom. The UK's first new nuclear power station in a generation under construction in Somerset. 2 EPR, European Pressurized Reactor units, will produce 3.2 gigawatts of electricity, enough to supply about 7% of UK demand. The project's intended to provide stable, low-carbon baseload power for decades. Each reactor building uses a double containment structure of pre-stressed concrete, with a heavy steel reactor vessel at the core. Massive tunneling works provide seawater intake and outfall systems for cooling. A specialized jetty was built to bring in large prefabricated components by sea. The EPR design features a core catcher for severe accidents, 4 independent safety trains, and high thermal efficiency. Cooling towers are not used. Instead, the plant relies on direct seawater cooling. It'll provide electricity for about 9 million homes, supporting UK decarbonization targets. It also establishes supply chain skills and infrastructure for future nuclear projects. Estimated cost is around £32 billion. Financing comes from EDF, France, and China General Nuclear, CGN, with long-term revenue secured through a contract for difference with the UK government. Main civil works began in 2017. First reactor startup is currently targeted for the early 2030s, after scheduled delays. Rail Baltica, Estonia, Latvia, Lithuania, Poland. An 870-kilometer high-speed, standard-gauge railway connecting the Baltic states to Poland and the European rail network. It replaces the region's legacy Russian broad gauge and is part of the EU's 10T North Sea Baltic corridor. The line's being built as a double-track electrified corridor with 249 kilometers an hour passenger design speed and 120 kilometers an hour freight capability. It requires new bridges, viaducts, and tunnels across rivers and wetlands, as well as urban passenger stations in Tallinn, Riga, Kaunas, and Warsaw. It's fully electrified with 25 kilovolt AC, ETCS Level 2-3 signaling, and provision for cross-border interoperability. Freight terminals and intermodal hubs are integrated to boost trade. Travel times will shrink. Tallinn to Riga will be cut from 4 hours by bus to about 2 hours by train. The project also ensures strategic military mobility across NATO's eastern flank, in addition to civilian use. The total project cost is estimated at €5.8 billion. Around 85% is funded by the European Union's Connecting Europe facility, with the remainder from national governments. Main works began in the 2020s. The goal is to complete and open the line by 2030. Messina Bridge, Italy. A planned suspension bridge to connect Sicily with mainland Italy across the Strait of Messina. If built, it'll span 3.3 kilometers with a main span of 3,300 meters, longer than any existing suspension bridge. The project aims to integrate Sicily into the Italian high-speed rail and motorway networks. The design features a single span without central supports to allow uninterrupted shipping traffic. The deck would carry 6 road lanes and 2 railway tracks. Towers about 382 meters tall would support cables nearly 1.2 meters thick. Foundations must be anchored in complex seismic and windy conditions, requiring deep geotechnical work. Once operational, the bridge would cut crossing times from an hour by ferry to a few minutes by train or car. It's expected to carry millions of passengers annually and facilitate freight movement between Sicily and continental Europe. Cost estimation is around 14 to 15 billion euros. Funding would involve Italian government resources and potentially private investment, though financing remains debated. The project's been revived and cancelled multiple times. In 2023, the Italian government announced new steps toward construction, with completion potentially in the 2030s if contracts are finalized. London Tideway Tunnel, United Kingdom. A 25-kilometer super sewer under the River Thames, under construction to stop untreated sewage overflows into the river during heavy rainfall. It'll intercept and redirect combined sewer overflows into a new tunnel leading to upgraded treatment works at Beckton. The tunnel is 7.2 meters in diameter, excavated with tunnel boring machines running deep below the Thames at depths of 30 to 60 meters. Vertical shafts connect to existing sewers at multiple points. The concrete lining and waterproofing are engineered for 120 years of service life. It's designed to protect the Thames from pollution, improving water quality, biodiversity, and urban environment. It'll handle up to 39 million tons of wastewater annually that currently spill untreated. Project cost is about £4.5 billion, funded through a special purpose company licensed and regulated by Avoir, with costs ultimately recovered through water bills. Tunneling began in 2016 and was completed in 2022. Final system integration and commissioning continue, with full operation expected by 2025. Copenhagen Metro Cityringen, Denmark. A 15.5-kilometer underground metro loop encircling central Copenhagen opened in 2019. It adds 17 new stations and doubles metro capacity in the city, cutting travel times between districts by bypassing surface congestion. Bored with 4 tunnel boring machines operating simultaneously in soft glacial soils, stabilized with grout injections and slurry shields. Each station was built using cut-and-cover methods with diaphragm walls sunk up to 30 meters. Fully automated, driverless trains operate every 100 seconds at peak. The loop integrates with the original metro lines and suburban S trains, serving about 300,000 passengers daily. It reduces car dependency in a city already oriented towards cycling and public transport. For construction, about €3 billion were financed by the Danish government, City of Copenhagen, and user revenues. Swiss Deep Geological Repository, Switzerland. A planned permanent repository for spent nuclear fuel and high-level radioactive waste, to be built at the Nordlicht Lagern site near Zurich. It represents one of the most ambitious subterranean engineering projects for nuclear safety in Europe. Engineered caverns and tunnels will be excavated in stable opalinous clay formations about 600 meters deep. Waste will be sealed in copper-coated canisters, surrounded by bentonite clay buffers, and placed in horizontal tunnels. Multi-barrier containment ensures isolation for hundreds of thousands of years. It provides Switzerland with a long-term solution for radioactive waste management, meeting international obligations and ensuring public safety. Its costs are estimated at €20 billion over its lifetime, funded through a levy on nuclear electricity generation managed by a national waste fund. Licensing and approval processes are underway in the 2020s, with construction and emplacement planned from the 2030s onward. WestConnex-like Grand Project, E39 Coastal Highway, Norway. Norway is transforming its west coast road network into a continuous ferry-free highway, E39, stretching about 1,100 kilometers from Kristiansand to Trondheim. This program involves multiple megaprojects, including record-breaking floating bridges and submerged floating tunnels. Conventional bridges and tunnels are combined with novel floating structures to cross wide fjords where depths exceed 1,000 meters. Submerged floating tunnels, tethered to the seabed or pontoons, are under active development, the first of their kind globally. Each fjord crossing is engineered independently with wind, current, and seismic modeling. The E39 will cut travel time between southern and central Norway by half, integrating remote coastal communities into national and European road networks. Freight transport efficiency will rise sharply, boosting competitiveness of Western Norway's industries. The overall corridor cost is projected at more than 40 billion euros, spread over decades, funded by the Norwegian government with partial tolling and public-private partnerships. Segments are under construction and open in phases. The full corridor is targeted for the 2040s.